to do some revision or study on the number system. Understand, class?
Understand.
What happened with the Google Docs? Sometimes something happened with Google Docs. When you want to view the Google Docs, it says this one. You can see the display on my screen. Docs can display some features of this Word document. I don't know why. Okay, it's okay. All right. Have you update me regarding your group project? Project. Okay. Attendance. After this, I will update regarding your attendance. Later on, you can update your attendance here. Right. Unshare first. I want to see your update regarding the group project, group assignment. Okay, so I can see that. Berapa orang tak ni? Satu, dua. 2% not yet put your name inside the column. Okay, now you can see my screen. So I want you to update your name here. So please ensure, make sure that you put your answer, your name. Don't put it blank. Right, so I can, right. Yes. Ya ke? So what happened? Maybe something need to be configured at his side, I think. Okay, so let's continue with our mission today. So basically, this is the topic that you need to cover, all right? Right. So, computer memory system, yeah? So basically, we want to talk about the computer of the memory system. In the computer, so basically you have the three main components. That is the CPU, that is the main memory, and another one is I/O device, input output. So basically the CPU, yes, we already completed. Okay, how about main memory? What is the function of main memory? What can we understand about the main memory and so on, how it works and so on. Okay, so you can see that this is the chip for the main memory. Okay, that contain very small here. This is the location to put your memory, and then this is the main memory, and then it actually consists with transistors and capacitors. Yeah, transistors and capacitors. So let's go back here. Okay. Transistors and capacitor. memory. Okay, so basically we have the component actually contains from the transistors and capacitors. So in yeah, okay. So actually this is the memory cell. You can see this one. Okay, so this is the transistors, yeah, and then this is the capacitor. Okay, and then this is the connection, the ground. This one only one cell of memory. Okay, so this one basically consists of one cell of memory. Okay, from this one example. Okay, so this one. So basically we have the transistors and also capacitor. All right, this capacitor will link with the ground, and transistors basically we have open and close here. So for the word to come here, actually it will put in address mode. In address word come in address line lah, yeah, to put here inside, and then the output here as well. Okay, so this is the column address in a very one's memory. Okay, so in one memory cell, actually it has many transistors and capacitors, right? So in one room or one box of transistors, capacitors, basically, single memory, one cell of single memory cell, basically it consists of one transistor and one capacitor. Okay, all right. So yeah, actually, in memory technology, categorize how data is stored. Yeah, either it is volatile or non-volatile. All right, either temporary or Mhm. Either temporary or temporary or why? Okay, tak apa. Either this one is volatile is for the temporary, non-volatile for the permanent. Okay, and then the method of access the information or data inside the memory cell basically in terms of random or sequential, right? So this one we will go through in detail in our slide. Here. So we will discuss 4 subtopic for this memory system of our computer. So introduction, what is internal memory, external memory, and also cache memory system. Okay, so why do we need another one cache? We call it cache here in our memory system. All right, so we'll study on this. So this is the computer memory system. Generally, computer memory system can be divided into 2 categories. Okay, first is internal memory and the second one is external or secondary memory. So you can see here, this is the inboard memory. Inboard memory actually in the pyramid in terms of the how big the capacity of it. In the pyramid, basically it was at the top. Okay, so it consists with the registers, cache, and main memory. Okay, and then the outboard storage here, the second layer from the top. Okay, outboard storage. So outboard storage basically consists of magnetic disk, CD-ROM, CD read write, DVD read write, DVD RAM. Okay, and then this one is the offline storage. In terms of capacity, actually, this capacity and size and also power. How powerful is your memory? Okay, so the more higher, the more capacity, more size, and also more expensive actually. Yeah, more expensive in terms of cost. Okay, so this one is offline storage. We can call it as a magnetic tape, MO, WOM, and also hard disk, external hard disk, also categorized under offline storage. Okay, so this is the memory hierarchy. Okay, it show you decrease cost per bit. Yeah, of course, if this one, okay, cost decrease. Okay, and then shorter access time, greater cost per bit. So, shorter access time, greater cost per bit. Yeah, of course, the access, it also consider in terms of access time. Access time here is refer to the how fast is data is fetched and execute. Yeah, access time. Increased capacity in terms of internal memory is much smaller than external memory. Yeah. So in terms of capacity, of course, the size much smaller than external memory. So yeah, you can see that this one, okay, very small, but it has millions of transistors and capacitors reside inside one memory, main memory. Okay. Increased access time, it is always faster to access data from internal memory and greater capacity. So a longer access time. Right? Decreased frequency of access by the CPU. Right? So yeah, we need to let in. Okay. Hi Zakwan. Hi, how are you? You can hear my voice? Zakwan?
Yeah, yes, now, yes.
Okay, very good. All right. Okay, so keluar lagi. Alright. So we have internal memory here. Alright. There are three types of internal memories. Yeah, we have cache, we have registers, we have main memory. So main memory here will consist of RAM and ROM, random access memory, and read-only memory. So cache here. Okay, so here actually we will look into it. How is the architecture of the cache and why actually it need to be inside the memory. So three types of internal memory. All right, and then registers here. Okay, basically memory will be put or located in the CPU. All right. Okay, this is the three types of internal memory. All right, so the registers here actually the type of memory, internal memory, but it resides in the CPU. Remember, inside the CPU, it must have the registers, it must have the LU, ALU, it must have the CU. Okay, these three things must reside into the CPU. Okay, another registers here, actually this registers is type of memory. Okay, but it resides in the CPU. And it actually a resident for the CPU. CPU also has the registers. Okay, another one is cache, and then another one that we commonly know that main memory will contain with from the RAM and ROM. Okay, this is the three types of internal memory. So information stored, if I just to recall for you, if I call So it will refer to the RAM and ROM. Remember, so yeah, type of registers, as I mentioned, also type of memory, internal memory, but it resides in the CPU. Okay, but it is a resident for the CPU, component for the CPU. Alright, information stored in internal memory can be accessed with greater speed by the CPU compared to external memory. So internal memory is contained in CPU chips and uses electronic circuits to store information. So as I mentioned, it consists the component inside in a cell memory is actually from the transistors and capacitors. All right, internal memories are volatile. So volatile here is a temporary, only with the exception to ROM. ROM here is actually non-volatile or permanent. So once you save inside the ROM, so basically ROM will store it permanently. Okay. But ROM also a category of internal memory. So unless you have the external hard disk and so on, that one categorized under the external hard disk. Okay, so ROM here is consider of under this one, outboard storage. CD-ROM, this one category for the outboard storage. It also has the memory inside. Okay. So the main memory here is the central storage of the computer used to store instruction and data that are being executed. Because you need to store the instruction and data to be executed. So store here we call a buffer, isn't it? So buffer is a mechanism to queue the instruction inside the memory. They are built based on semiconductor integrated circuit. So basically they are divided into ROM and RAM. Semiconductor integrated circuits. So like I said, they call also like this because it consists of on-off binary digit with transistors and capacitors to control the semiconductor integrated circuit, SiC. Okay, so this is the thing for you to understand about how actually memory work for us. Okay, how it store the data, how it store the instruction, the address of the data and so on. Okay, so in the main memory, there are unique address for each location. We know that in the memory, there is unique address. Remember I told you about the houses in your taman? Of course, it has the address. Where is Ah Chong's house? Where is Ahmad's house? Okay, and then the data inside the house is how many person stay or reside inside the house. Okay, so basically the data and also the location the address of the location must come together. Okay, same like the built in the structure or the architecture inside the memory. Okay, so this is the basic memory structure. Okay, so assume that this is the memory. Okay, of course, the memory has the mechanism to read and also write. Okay, so for the memory to store the data, it needs the address where to find the places to store the data. Okay, so and then the data bus will use here is to transfer or to transmit the data from the memory to another devices, some like I/O devices and so on. Okay, so N here refer to the address bit. Address must be in the bits. Bits. So bits here will be in 0, 1, like that, in 0, 1 like this. And remember 1 byte, okay, equal to 8 bits. So the n address bit can address 2 to the power of n location. So n here we refer to the address. Okay, so n here we will refer to the address in a bit format. In a bit format. So access one word at a time. Okay, only one word at a time, because in memory we save the data in a word format, in a word. Okay, so basic operation are read and write. So this is the basic operation of the memory. Okay, so why is memory size is 2 to the power of n or 2n location? Okay, so this is some explanation to you. Computers use a base 2 system, yeah, base 2 system that is 0, 1. Okay, for base 2, we use 2 to the power of n to find combination of numbers. So 3 digits equal 2 to the power of 3. So it will give the result of 8. So 8 here is a different number. Different number. Similarly, 2 to the power of 4 equal to 16, to the power of 5, 32, etc. So it makes sense that memory is in power of 2. Yeah, because it has a base 2. Okay. Base 2 here is referred to the 0, 1. Okay. Okay, so this is some explanation of the RAM, type RAM inside the under category of MM. So RAM here is actually for random access memory. So actually information in RAM can be read and also modified. So meaning that you can read, you can save, and then you can open it back and then write it back. It will rewrite back. So modified here, changes can be done in the RAM. Used to store programs and user data that is being executed. Yeah. So this is actually the RAM function. When an instruction set or program is typed into a computer, the program is stored in a part of this main memory called RAM. Okay, then the computer is switched off, the program will disappear from the RAM. Okay, this is commonly happen to you. Okay, when you are doing something in the Word, for example, but you didn't save it, and then you can view it for 3 hours of what you type in your Word. Yeah, but then if you switch off the computer, basically your what is the type, the text that you already typed in the Word already disappeared if you didn't save. So this is the common thing that you need to understand about the RAM. Okay, RAM will not save. Okay, it just start temporarily. Yeah. A kind of volatile memory. Okay, temporary. The content in RAM will be wiped out if electricity supply is interrupted. All right, so types of RAM, we have the SRAM, static RAM, and then also DRAM, dynamic RAM. Okay, static RAM is actually made from flip-flop. Yeah, a logic circuit which retains the information stored in it as long as there is enough power to run the device. Okay. Disadvantage of the SRAM, actually it is very expensive, small storage capacity in a chip. But advantage of static RAM, easier to use and fast access time in terms of read and write cycle. Okay, so how about dynamic RAM? So dynamic RAM actually made from the capacitors. Yeah, kalau from the static RAM here, actually it made from the flip-flop. Okay, class, is there anyone, if you notice that your friend want to enter this group, please update me, because I afraid that I have not see the alert. Okay, so let's continue. So the dynamic RAM here actually has disadvantages. Okay, The advantages here is lower access time, harder to use because capacitors need to be charged. Yeah, capacitors has some what we call the nature of capacitor need to be charged. So it need to be always refreshed for a certain amount of time. But flip-flop do not have to refresh. Okay, it will, because it has a consists of logic circuit that contain information as long as there is enough power to run the device. Okay, so the DRAM here, the advantage of the DRAM, it is cheaper, bigger storage capacity in the chip. So a few improvements have been done on the DRAM in order to improve its performance or access time. Of course, when we are dealing with the with the memory, with the CPU, the performance is very critical. So criticality here is measured in terms of access time. How much time, how many times is required, how many seconds required, or how many milliseconds required to access the information or the data. So this is called the access time with different method and names. Example, EDRAM, CDRAM, SDRAM, RDRAM, and so on. So EDRAM here is for embedded DRAM. Okay, CDRAM here for the cache DRAM, SDRAM for the synchronous DRAM, and also RAM bus DRAM for RDRAM. Okay, so this is the explanation for the types of RAM, that is the SRAM and also DRAM. So remember the differences, the big differences of static RAM and also dynamic RAM is in terms of the what it was made from. Okay. Okay, so now we are looking at the block of diagram for a unit chip RAM that has 2 to the power of k word. Yeah. And the length of each bit is n bit. Yeah, it has n bit. Okay, so let's see here. Of course, in the RAM, this is the word and length of the RAM inside. The capacity, what we call here is capacity of internal memory, is typically expressed in terms of the bytes or words. 1 bytes equal 8 bits here. So this is the capacity for this RAM with 2 to the power of k times n. So k here is the line for address. Line for address. So it comes from the address bus. Okay. And then, of course, this one is the main function of RAM. So basically, who control this read and write? So basically controlled by the controller bus, the police, the bus police. Okay. Okay, so the input, in terms of input, actually it has the N input line. This one from the data bus. Okay, because the data that you want to be input into the RAM must be in address format. Yeah, and address line. All right, and then the data insert the address is actually in N format. So N format here is actually an input line, okay, from data bus, and then actually in the RAM, so this one will be the N bit length. Okay, so N here, and this is the capacity of RAM. 2 to the power of k times n, and here is input line. So input line also equal with the bits line of the RAM. Okay, so for the address line here, it will denote as how many address line that you have. All right, so it will actually refer to the 2 to the power of address line word in your memory. Okay. Okay, understand class?
Understand.
Okay, so let's continue with this. Okay, let's see how you can calculate for the capacity for the memory. Okay, example, we have here 2 to the power of 24 times 16 RAM. Memory contains 2 to the power of 4 equals 16 M words. All right, so each 16 has a bits, 16 bits long. Okay, so remember this one is N, okay, this one is K. Okay, and then this one is N bit length here, okay, for this memory. So this one 2 to the power of actually this one for the K. So here is 2K times 2 to the power of 24 times 16 bits length. Sometimes they will give you 8 byte here, example, 8 byte, but you need to transform to the bits format. Okay, so all right, so how do you get this total capacity 16 here? Okay, so let's have some total capacity for this 16 for this 2 to the power of 24 times 16 bits. So how to calculate it? Basically, you need to 2 to the power of 4 24 times 16 bits, okay, equal, you need to transform the 16 into power of base 2, okay. So how do you get the 16 here? So basically it comes from the 2 times 2 times 2 times 2, okay. 2 times 2 is 4, 4 times 2 is 8, 2 times 2 is 16. All right, so this is how you get the 2 to the power 16 here. So it's 2 to the power 4. Okay, so it will equal to the 2 to the power of 28 bit, because 2 to the power of 24 plus here is just plus, okay, 24 plus 4. So you will get 28. All right, so 2 to the power of 28 bits actually in a bytes is 2 to the power of 25 bytes. So how do you get 2 to the power of 25 bytes here? Do you know how, class?
Divide 8.
Divide 8. So how do you divide 8? Okay, so you have 2 to the power of 28, yeah, divide by 8. Is it like that, class?
2 power of 3.
2 to the power of 3. Okay, just minus 28 minus 3. Okay, so correct. So anyone has question? Maybe there's some of you cannot follow about this calculation. Anyone, class?
Doktor, kenapa kena divide by 8
Sebab this one is the bit. So you need to transform into the bytes format for the total capacity. So 1 byte equal to 8 bits. So when you want to transform, you need to divide by the bits. 1 byte equal 8 bits, so you need to transform this one.
Oh,
Okay?
okay. Okay, thank you, Doktor.
Welcome. Okay, so we have question just for you to have some basic understanding on to have the total capacity in your RAM. Okay, so this is the question. How many bits will you need to address 2 million times 32 memory if the memory is byte addressable? So meaning that your answer must be in the byte And the other one is the memory is word addressable. All right. So can you do it now? Try to look at this first. Okay, and then try to relate this one. So how do you can calculate for 2 million times 32 memory? Can you do it now? I will give you 10 minutes. 10 minutes. 5 minutes good. 5 minutes
Okay.
I think sufficient. All right. Try to do it. So class? Okay? Ada yang dah siap? Anyone of you already completed? Try to answer A first. So meaning that your memory here is in byte addressable.
Um, Is it the answer is 223 bytes?
Bits. 223, yes.
Yes, for the A.
For the A, eh? So 23 here are bits that are needed for an address. Okay, very good. So other than you, some.
Doctor,
Yeah,
is it possible if we give answer in decimal form?
decimal. How?
2 to the power of 23.93169.
2169. Why there's a decimal form?
Because 2 million is 2 to the power of 20 point something something.
Oh, I see. Okay, you just ambil yang the round number je lah.
Oh, round tu nak plus ke nak minus?
This one is plus tak? Plus lah, biasanya plus lah. This one tak ada kaitan dengan minus ni.
Okay.
Hmm.
So kalau plus should be 2 to the power of 24. Kan?
Tak lah. Huh? How did you get it?
Sebab kalau 2 million 2 to the power of 20.9. So kalau round off dia akan jadi 2 to the power of 21.
Oh, okay. So macam ni je lah. You just get the round number. 1 million equal to, you just ambil dulu 1 million kan. 1 million is just equal to 2 to the power of 20. If you have 2 million, so meaning that times 2 to the power of 20 times 2.
Oh.
Okay. So you will get 2 to the power of 21. Okay, siapa lagi yang tak clear? I can just write it down here. For A, macam ni Okay, for A, you just mula-mula you settlekan 1 million, alright? So it's equal to the power of 20. Then if 2 million here, so it will be coming 2 times 2 to the power of 20. So this one, of course, 2 power of 1. So it will become 2 to the power of 21. Okay, Sarah? Who asked me just now, Mimi or Sarah?
Mimi.
Mimi. Okay. So there are 2M 4 bytes. 4 bytes. Okay. So we need to transform right now because there are, okay, I just tulis kat sini, there are 2M. How many bytes here? Okay, to have 32 here because this one is in the bits. Bits, bits. For not really confused. So this one will be how many? Times 8 bits. 4 lah. This one is it? Isn't it? Correct? Class?
Yes.
So this one will be 4. Okay, so now 2 to the power 2 million, okay, times 32, come back here, 2 million times 4 bytes equal to 2 to the power of 21 times 2 to the power of 2, sorry. So that's why you get 2 to the power of 23. Okay, so we can conclude that Therefore, 23 bits are needed for an address. For an address. Okay? So clear here?
Doctor,
Hmm.
kalau if my answer is just like the previous slide, is it correct?
Correct as well.
Oh, okay.
Yeah, correct. Because this one I want you to have proper way how to answer it. How about this one, B? How do you read?
8 million word.
Pardon? Tengah buat. Okay. Buat.
The answer is 8 million words. Is it?
Sama juga. The answer in the bits. Tetapi it will store in the word addressable. In the type of word addressable. Yang ni you need to convert. You need to convert the bytes here. In the word, kan dia ada how dia, remember this one, this slide? Mana I cakap tadi? Tak ada kat sini. This one. For the address. For the address, it's stored in bit 01. So access one word at a time. So one word here actually in the 01. 01 format. Do you have Abdi Shakur here? Class? Abdi Shakur. Muhammad Abdi Shakur Abdullah. So, yeah, I need to check with the attendance. Last week dia datang ke tak?
Last week dia ada rasa
Ada